Hey everyone, it's that math magician. On this video, we're going to continue to look at probability, but now we're going to learn what combinations are, how we can use them in these probability questions, and how the formula is actually very similar to permutations, and so we can use a very similar formula to help us solve these problems out. So let's go ahead and look at what combinations are. Remember, permutations, that's where the order matters. Combinations are where the order doesn't matter. And that's the big key difference between what a permutation is, what a combination is. Permutations, I care about the order of the things I'm picking. For example, we were looking at using our PIN for our ATM card. The order that I put those numbers in matters. Okay, with a combination, the order doesn't matter, right? A PIN number would not work for combinations because we have to have the ordering matter here. For combinations, the order doesn't matter. The best way that I always explain to my students about how to think about what a combination is, think about going to the drive-thru at McDonald's and you're ordering a combo, short for combination. If I order a Big Mac, some fries, and a soda, right? The order doesn't matter of when I order those things, right? It doesn't matter which ones I pick first. Big Mac, fries, and Coke, that's the same as fries, Coke, and Big Mac. I've ordered the same thing, right? The order there doesn't matter of when I select it. I could say I want a Coke and a Big Mac and fries. I'm still going to get those same three things. It doesn't matter. The order there does not matter. Now, what's really nice is that we have a formula for permutations. We learned it in our permutation video. If you haven't seen it yet, I would go check that out first. It's right there. NPR, and it equals n factorial over n minus r factorial. Remember here that n tells us the number of items you have, and R represents the number of items that you choose. And what's nice is the notation for permutations is the exact same notation that we're going to use for combinations. We just got to tweak it. Okay, we got to tweak it because a combination is really a permutation, but now the order doesn't matter. I don't care if I have one combination of items where it's the same as the other. We need to remove those out. So here's how we're going to write that out. We're going to have a capital C this time for combinations. We're still going to have the N and the R next to it. The N and the R are still being represented by the same things. N is the number of items that you have. R is the number of items that you're choosing from the N. And what's nice is you're also going to have a factorial fraction. You're still going to have n factorial on top. On the bottom, part of it is still going to look the same, the n minus r factorial. But we need to add one more thing down there. And this last piece that we need to do is we need to put in r factorial. The reason why we put r factorial in is because we're removing all of the multiple combinations that are the same in there. And it'll make sense in a second when I do an example problem with you. But that r factorial on the bottom is super, super important because it removes all the extras, all the duplicates, all the ones that are really the same that we don't need to have in there. If you use that formula every single time for combinations, it's going to help you out. Okay, now let's see this formula in action and let's look through an example problem that will hopefully help you understand that a bit more. Let's say that I need 3 students to help me move. Maybe I'm moving classrooms. So I'm picking 3 students to help me move out of 5 students who maybe stayed after school to help me. Okay? I'm choosing 3 students out of 5 students who have chosen to help me. Those 5 students, let's give them some names. We could have Al. We could have Barbara. Let's have Carl. We'll have Dane. And then we'll have Eric. Okay, those are our 5 students that are going to help me move some stuff from maybe one classroom to the other. And I want to pick 3 of those 5. Now, we have to first think now, okay, I need 3 students to help me move stuff after school. 5 showed up. Is the order going to matter here for the students that I'm picking to help? Okay, for example, what if I picked Al, and then Barbara, and then Carl? Okay, I picked Al first, I picked Barbara second, I picked Carl third. Is that any different from me picking Carl first, then Barbara, then Al? Does that order actually matter? Or does it not matter who I pick first as long as I have those 3 kids? I think it's the latter here. I don't think the order matters here because I just need 3 students to help me. In this case, those 2 options there are really the same, right? Al, Barbara, and Carl is the same as Carl, Barbara, and Al, which is also the same as Al, Carl, and Barbara, which is also the same as Barbara, Al, Carl. All of those are representing the same 3 students. The order does not matter here that I'm picking them in first, second, third place. Maybe it would matter if those 3 students were, maybe those 5 students were running a race, and maybe we're picking first, second, third. That would be a permutation, right? The order would matter if I was saying, oh, the first person, the second person, the third person, you're going to win medals. Maybe you also win some money. That's when the order matters for when I pick them, right? You want to be picked first because that means you got first place. You're going to win the money. But if I'm just picking 3 students to help me move something, the order actually doesn't matter here. These all end up being duplicates that when I'm finding out this combination, I don't want to count all of them, right? I just want to count one of those, the ABC. I don't need the CBA, the BAC, the ACB. They're all the same. So that's why we want to use our combination formula here. That combination formula is going to help us, and hopefully it starts to help us understand why it is the way that it is. So let's set it up. I got my big capital C. How many students am I choosing from? How many students do I have to choose from? Well, we have 5. Of those 5, I'm picking 3 students. So using that formula, our factorial fraction will have a 5 factorial on top. On the bottom here, we know the drill, just like permutations. I'm going to do 5 minus 3 factorial. But right next to it, I need to add in the r factorial. Look at that formula there. I'm putting in my numbers in that I need. I have n minus r, 5 minus 3 factorial, gives me the 3. And now I have to plug in the r factorial. This is going to simplify to 5 factorial over 2 factorial times 3 factorial. The reason why we have that r there, I'll highlight it again. The reason why we have that r there is because it's removing those duplicates that we just talked about, right? There is no difference from me picking ABC or me picking ACB. Having this 3 factorial on the bottom, making it a combination and not a permutation, removes those extras. And now I just have to simplify this out. And again, we could do it by hand. And if I do it by hand, I would have 5 times 4 times 3 times 2 times 1 on top. On bottom, I would have 2 times 1 times 3 times 2 times 1, because I got 2 factorials there. We could cross out the parts that we recognize. Well, look, the 3s, the 2s, the 1s are going to cancel. I don't really need the 1 there. And I have just, let's see, 5 times 4 on top. Well, 5 times 4 is the same as 20 over 2, and 20 divided by 2 means that there's only 10 different combinations, 10 different ways that I can pick 3 students out of those 5. The order doesn't matter. So it's removing all of those duplicates. Had this been a permutation, that number would have been a lot more. And if you don't believe me, let's just see it as a permutation. Let's say maybe that the order now all of a sudden does matter, even though it doesn't. But let's see. If I make this into a permutation problem, I would have this using my formula, right? Notice I don't have the r factorial there. This ends up just being 5 factorial over 2 factorial. And that would simplify to 5 times 4 times 3 times 2 times 1, all over 2 times 1. Look, I have less stuff canceling out. Less stuff reducing to 1. Because I don't have that extra number there in my denominator. I don't have that r factorial, so I don't have more things to cancel. It means I'm going to have a larger number, and that larger number is going to be 5 times 4, which is 20, times 3. If this was a permutation and order mattered, there'd be 60 different ways to order that out. But because this is a combination of those 60, I remove all the duplicates. There's really only 10 combinations. Okay? Your combination number will always be less than the permutation number when your n and your r are the same. Okay? When your n and r are the same. All right, let's try another problem. Just like this, let's see how we can use our combination or our permutation. Again, we got to think about what's going to be working here. Does the order matter? Does the order not matter? All right, let's say that we want to create a 4-person committee. We want to create a 4-person committee at school, right? We want to pick 4 kids that are going to lead a committee. Maybe they're planning our next dance, okay? And of those 4 people we want to pick, let's say that we ended up having 15 applications come through. Wow, 15 applications came through for our 4-person committee. We want to figure out how many different committees could we actually put together, right? Of those 15, how many different ways can I pick the 4 people to serve on this committee? The first question we have to ask is, does order matter or does order not matter here? I think in this case, since I'm just picking a 4-person committee, right? I'm not picking a president, a vice president, a secretary, a treasurer, right? I'm not giving them roles. I'm just saying I need 4 people to work on this committee. I think in this case, the order doesn't matter. And since the order doesn't matter, that means that this is a combination. And a combination means that we can use our formula that we know how to use. We need our capital C, and we need to figure out what our N is, where our N is the number of students that applied. So that would be 15. Of those 15, how many am I choosing? It's going to be 4. All right, let's create our factorial fraction. What goes on top? That's n factorial. What goes on bottom is n minus r. So for us, 15 minus 4 factorial. But remember, it's a combination. So I need to also put in an r factorial. I got to put in that 4 factorial to remove the duplicates, right? The 4-person committees that end up being the same because the order doesn't matter. Well, this is going to simplify to 15 factorial over 11 factorial over times 4 factorial. Again, we could solve this out by hand, or we could just use our calculator to help us solve this out, right? We can always use a calculator to help us because that's the option we have. I can do it a couple of ways. I can type in just the factorial fraction. So I could do that right here, 15 factorial divided by 11 factorial times 4 factorial. And I see that out of those 15 applicants, I'm picking 4 to make a 4-person committee. There's 1,365 ways of choosing those students. Again, we also have a button here that's going to be able to use for our combination formula. Look right here at function. Right here at the bottom left, we used permutation last time. There's NCR for our combination. Plug in the N, plug in the R. I'm going to plug in 15. I'm going to plug in 4. It also gives me my number of combinations, spits it out if I don't want to find out what that factorial fraction is. Okay, it's still 1365. Maybe some of you like solving it by hand. Well, if I really wanted to solve it by hand, I could start to write this out. 15 times 14 times 13 times 12 times 11. Notice I'm going to stop there because I already have an 11 factorial, right? I'm going to slide it over to the right because I know that those are going to cancel. On the bottom, I'm going to still have a 4 factorial. 4 times 3 times 2 times 1. Let's see if we can cancel anything out here. Well, look, 4 times 3, that's 12, right? 4 times 3 is 12, so I can cancel those out. And I'm just left with a 2 on the bottom. Well, 2 goes into 14 7 times. And 15 times 7 times 13, hopefully better equal what we just got. 15 times 7 times 13, it still gives us 1365. Okay? Again, 3 ways here to solve it. You can make your factorial fraction. You can just plug it into your calculator using the combination function. Or if you really like solving it by hand to see all the stuff cancel out, you could do it that way too. It's all going to work out for you. But what's important is you got to recognize whether or not, whoops, I did not want the red, I wanted my highlighter. You got to first recognize, does order matter? If order matters, it's a permutation. If order doesn't matter, it's a combination. And these are our two formulas that we'll keep using, and you'll always have to answer that question every single time. Does order matter or does order not matter? It's that Math Magician, and I'll see you on the next video.